All right, guys. This week we're going to review some linear functions, okay? Because they lead into our unit on statistics, which we're going to start next week. All right? So the first lesson we're going to do is rate of change, okay? And remember, rate of change is basically your slope, okay? So anywhere where they refer to the average rate of change or which has the greatest rate of change, you got to find the slope. So in the context of some applications, they might say, what's the average height, over a certain time period. When they use that type of language, that's your average rate of change or your slope. All right, remember your slope is your rise over run. Your rise is your y values, and your run is your x values. Okay, but what you have to do to figure out your rise is you got to figure out how far apart or the difference in the y values. And to figure out the run, you got to figure out how far apart laterally the x values are. So you got to do the difference in your x values. So basically your slope, or m, is equal to y2 minus y1 over x2 minus x1. Now if you want to just think of it as y minus y over x minus x, that's fine. But you have to stay consistent with the order. So I'm going to do a couple of basic examples. We're going to find the average rate of change, the slope, between these 2 points. Now what I recommend you do is you write them vertically, one above the other. So now I can match up my two y values and I can match up my two x values. It doesn't matter which one you start with, as long as whichever y you start with, that x goes first. So I'm going to do y minus y over x minus x. 2 minus 10 over, I got to go in the same order. So if I start with this y, I have to start with that x. 8 minus 2. And I'm going to get negative 8 over 4, which is negative 2 over 1. All right? I want to do some that have some negative values to make sure that we don't get thrown off. So I'm going to look at C, and later on you're going to try B. All right, I got 4, negative 6, and negative 2, negative 10. And again, it doesn't matter what order you go in. So I'm going to do this negative 6, right? It's y minus y over x minus x. So negative 6 minus, but the 10's negative, so I'm subtracting negative 10, and that's over 4, subtract negative 2. You know that this is going to become plus plus, same thing here. So negative 6 plus 10 is going to be 4. 4 plus 2 is 6. And in simplest form, 2/3. Okay? Now, this is where the applications start coming in. Number 1, it says the table below represents the height of a ball over time. Find the average height of the ball between 3 and 5 seconds. So, we're going to go from 3 to 5. But we're not going to look at the stuff in between. We're going to look at 3 and at 5. These are the values we're going to use. Now I'm going to rewrite them so that I don't get distracted by the other stuff in the table. This is all I care about. All right? All right. So here we go. Ready? Y minus y over x minus x. 10 minus 6 over 3 minus 5. 10 minus 6 is 4. 3 minus 5 is negative 2. You simplify that, negative 2 over 1. Sometimes they ask, what does this mean in the context of the problem? So let's take a look at the table for a minute. The ball starts out at a height of 0. It starts going up, 6, 8, 10. Once it hits 10, it starts going back down, 8, 6, 0. So what's going on is, most likely is someone threw a ball up in the air. The ball was going up until it reached a height of 10. then the ball started coming back down. So if they ask you, what does this mean in the context of the problem, our slope is -2. If it's negative, think about it, it means it's going down. So if I'm talking about the ball, and I want to talk about what it means in the context of the problem, you would say the height of the ball decreases. Think about the 2 represents feet. 2 feet, and the time is in seconds, per second. So if they ask you, what does this mean in the context of the problem? The height of the ball decreases 2 feet per second. Or you could say the ball drops at 2 feet per second. Either description is fine. They pretty much say the same thing. All right, I want to model one more question. All right, number 2. Sometimes you get something like this. Given the function g defined by the formula g of x equals x squared minus 4x, find the average rate of change. So how is 2 different than 1? 1, they gave you the table. Number 2, they gave you the function. So think about what we're going to do. We're going to plug the function in, and we're going to get this table of values. So I'm going to put this g of x in. X to the second minus 4x. You're welcome to look at the graph, but in reality, we want the table. So I'm going to go to my table of values. Now, I'm not going to look at any values. I'm going to look at certain ones, the ones they tell me. They're telling me to use this interval. 2 is less than or equal to x is less than or equal to 6, okay? If you see that. So I don't care about the x's in between. I care about when x is 2 and when x is 6. So I'm going to write a new table or a table of values, but I only care about when x is 2 and when x is 6. So I go to my table. All the other values don't matter. At 2, my x is -4. All right, you see that? And at 6, my x is 12. You only do the endpoints. The endpoints are 2 and 6. That's where I'm going from. All right, your slope is y2 minus y1 over x2 minus x1. All right, doesn't matter what order you want to go in. I like to go consistent. I'm going from top to bottom. -4 minus 12. You got to go in the same order. 2 minus 6. You're going to get -16 over -4. Now, something you may have forgotten. You could get a reduced fraction using the calculator. If I type this in, it's going to give me this number. But let's say it was a fraction. If I hit math, see that number 1's fraction, enter, it'll change it back to a fraction. Right? But that was a bad example. So if I go back to number, the do now, C. If you do 4 divided by 6, and you get this decimal, and you want to go back to a fraction, if you hit math, enter, it's going to give it to you as a fraction, 2/3. So if you get to a point where you're not sure how to reduce the fraction, all right, you could use that function. You put in the fraction, you hit math, enter, and it'll change it to a fraction reduced. All right? All right, I'm going to have you try the rest of these, all right, and I'll post solutions some other time. Talk to you soon.